Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 789. Page 789, and today is our lesson number 99. Let's turn to it. 789. Number one, question number 15, the very first one. It says how many integers in a set of all integers from 1 through 100 inclusive? 1 through 100 inclusive. We have to include the 1, we have to include the 100. In other words, we have to include the endpoints. Are not square of an integer. Are not squares of an integers. But before we worry about that part, why don't we ask ourselves this question: how many integers in a set of all integers from 1 to 100 inclusive are square of 100? Let's ask ourselves how many of them are squares of 100 of all the integers from 1 through 100, including 1 and 100. How many of them are square of an integer? The square of an integer is a bloody awkward way, it's a very verbose way of saying perfect square. In other words, how many integers in a set of all integers from 1 through 100 inclusive are perfect squares? How many are there? Well, there are 10 of them. 1 squared, 2 squared, 3 squared, so on and so forth. There are 10 integers that are perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Since there are 10 of them that are square of an integer, the square of an integer, as we just said, is another way, it's an awkward way of saying perfect squares. So from 1 through 100 there are 10 perfect squares, and the question here is how many of them are not? Since there are 10 of them that are perfect squares, which means there are 90 that are not perfect squares. There are 90 integers from 1 through 100 that are not square of an integer. 2 is not a square of an integer, 2 is not a perfect square, neither is 3, neither is 6, so on and so forth. That's it, the answer is 90. Let's go on to the next one then, number 16. Number 16. Listen, before we go to number 16, yesterday we came across a word in our lecture, and the word was underscore. And I was going to talk about it. I was going to tell you which day we learned it in our vocabulary lessons. And I forgot. And I erased the word. And I have the feeling that if I don't cover this word right away, I'm also going to end up erasing it, and we'll never figure out we'll never learn the day when we covered it. Underscore was something that we learned on day number 12. Just type in vocabulary day 12 and you will learn the word underscore along with some other interesting good words to know that will help you improve your score in the reading portion of the exam. Underscore means to highlight something, to underline something, to emphasize something, to accentuate something. Underscore. Verbose is another word that we just came across. It just means wordy, using too many words. And we learned this word, verbose, I remember covering it. There you go, on day number 16. Again, type in vocabulary day number 16, vocabulary day 16, and you will learn this word. Let's go on to number 16 now. In number 16, we are given a picture. It looks something like this. A to B, we are told. A to B, we are told, is 16. B to C we are told is 15, and then C to D we are told is 4. Now here's the question. This is the route that we are told a person takes. Let me read the problem to you verbatim. To say something verbatim means to say something word for word, exactly the way it was said. If you're quoting something, you can quote somebody and you can say that I'm quoting him verbatim. If you're quoting somebody verbatim, which means you are saying exactly the way it was said by that particular person, word for word. Verbatim means word for word. Notice verbatim is spelled with an I. It's not pronounced verbatim, it's verbatim, even though it has an I in it, verbatim. And when did we learn this word? We have to stop this thing because otherwise we'll never get to the problems. Verbatim, I know we learned it. Verbosity. What the hell? Doesn't appear. We have not learned it. Strangely enough, verbatim is not one of the words that we covered in our vocabulary lessons. I have to make a note of it, and we'll do it in one of the future videos of vocabulary. Alright? As of right now, there are 63 vocabulary videos and some quizzes. You will find them at my channel. So here, let me read the question to you verbatim. The picture above shows, well, already I messed it up because it doesn't say picture, so I'm going to paraphrase it, which is the antonym of verbatim. Do you understand? To say something verbatim and to paraphrase something, which means I'm going to say it in my own words. The picture above shows the route Diane takes from her house to her job. Alright, so here is her house. She drives from point A to point B, and then she goes from B to C, obviously, drives another 15 miles, then she drives from C to D, another 4 miles, and this is her work. If she were, now notice what they say here, if she were able to travel from A to D directly, my question is, why were? Why didn't they say if she was? Which is how I hear a lot of the people speak. If I was able to do it, I would have done it. No, it's not if I was. It should be if I were. Why were? Why were here? Even though this is a singular pronoun, I'm digressing again. We're doing the math problems. I am fully cognizant of the fact. But let's just do it since I started it. Why were? Because it's a hypothetical statement. When one speaks hypothetically, this is one of the peculiarity of the English language, one of the quirks, one of the eccentricities of the English language. English language is a very eccentric language. It has a lot of the times no rhythm or rhyme. And one of the quirk is that when one is speaking hypothetically, one has to employ plural verb even if the subject of the sentence is singular. If I were hungry, I would have asked for something. Do you understand? If I were hungry, I'm not. I'm speaking hypothetically. If I were, I would have asked for some food. If she were able to drive directly, this is the route she would have taken, obviously, and the question simply is, how much shorter would this distance be? Let's see how this is. How much shorter in miles would the trip be? That's what it is. Enough said. Let's do the problem. We're going on and on about nothing. So here's the tip. First of all, I'm going to make it a straight line. I don't like the way it looks. What we notice here is that distance from B to, we have B, C, D, and let's call it E. Distance from B to E, we notice is same as C to D. C to D equals B to E, which is 4. Now I want you to look at triangle ADE. ADE. In triangle ADE, what we have is this part. A to E. In triangle ADE, A to E is 16 plus 4, which is 20. D to E, same as C to B, which we are told is 15, and the question simply is how much is A to D, which is our hypotenuse. And how does one find hypotenuse? Given the fact that this is a right angle, how does one find, and how do I know this is a right angle? Because they tell you that. If you look at the picture, they tell you that this angle is a right angle. Otherwise, we couldn't just assume, we couldn't take liberties. So we're just going to simply apply Pythagorean theorem and figure out the distance from A to D, which is the hypotenuse of the triangle ADE. ADE. In this triangle, A to D is the hypotenuse. We're going to just figure it out, and we're going to subtract the two distances, and that's how much shorter it's going to be. So let's do it up here. So in triangle ADE, we have x squared, which is the hypotenuse here, equals this part here, the base, which is 16 plus 4, which is 20 squared, plus 15 squared. 20 squared is 400, 15 squared is 225, 400 plus 225 is 625, and x would be square root of 625, and square root of 625 is 25. So she's going to end up driving 25 miles. How much does she drive ordinarily? Let's find out. Her ordinary route would have been A to B, which is 16, and then B to C, which is 15, and then from C to D, which is 4. So 31 plus 4 is 35. Now she drives 25 miles going straight from A to D if she could do it, if she were able to, in which case she will drive 10 miles less. The answer is 10 miles less. That's it. One last note that I want to make before we go to the next problem is something I hope that you were able to see right away. This work that we did here of figuring out the hypotenuse of the triangle ADE, all of this was something that if I saw some student doing it during the exam, that would not be a good sign. That is not a sign of a good student. That is not a sign of a student who is about to get a decent score in math. This is something we should not have had to do. This is something we should not have had to do. Why? Because the triangle, let me put the triangle, let's do it here in the bottom. The triangle AED, A to E is 16 plus 4, which is 20, and D to E is 15. And the question is, how much is this one? We should be able to see immediately that this is a 3, 4, 5 triangle incognito. I'm going to redraw it. This is drawn in a horrendous manner. A, D, E, 20, 15, and this is, it's a 3, 4, 5 triangle. A 3, 4, 5 triangle is a freak of nature. A 3, 4, 5 triangle is a freak of nature. It's a right angle triangle where the three sides happen to be 3 consecutive integers, 3, 4, 5. The problem is that when a 3, 4, 5 does appear in the exam, it does not appear as a plain old 3, 4, 5 triangle. Here I am, look at me. It does not. It appears incognito. It appears in disguise. A 3, 4, 5 triangle, the vast majority of the time, appears incognito, and you have to be quick enough to recognize that it's a 3, 4, 5 triangle. And if you're able to do that, you will save yourself a couple of seconds. This is a 3, 4, 5 triangle. I see a 15 here, which is same as 3 times 5. I see a 20 here, which is same as 4 times 5. So we have 3 times 5, we have 4 times 5, so this should be 5 times 5. Voila, x is 5 times 5, right here, 25. We didn't have to do any of this thing, wasting our time, if you could actually see that immediately. Do you understand? And if you do not know a 3, 4, 5 triangle well enough, and if you want to get some practice in it, if you want to get a little bit more acquainted with it, then what I would suggest to you is to type in this tag, Geometry for SAT, Day 7. Geometry for SAT, Day 7, and watch that video. Watch that video and you will get something out of it. Do you understand? Enough said. Let's go to the next one, number 17. When did we learn the word incognito? I do not know. When did we learn it? I know we learned it. Incognito, in disguise, comes from the word cognition, which means knowledge. incognito. There you go, day number 42. Day number 42. Again, type in vocabulary, day 42, and you will find it. Number 17. One circle has a radius of half. Alright. So the radius of one circle is half. And another circle has a radius of 1. Another circle has a radius of 1. Since this one has a bigger radius than this one, I'm going to call it the small radius and the large radius. Question simply is, what's the ratio of the area of the larger circle to the area of the smaller circle? Basically what they're asking is, can you tell us what is the ratio of the large circle to a small circle if the radius of the large circle is twice as much as the radius of the small circle? If the radius of the large circle is twice as much as the small circle, the area of the large circle is not twice as much. It's something different than that. Let's find out, shall we? Area of this one is going to be pi. Area of the small circle is going to be pi r squared, which is half squared. And area of this guy is going to be, area of the large circle is going to be pi r squared. And they're looking for the ratio of the large circle to the small circle. Large circle is pi r squared, which is just 1 times pi, which is pi. And on the bottom we have pi times 1 half squared, which is pi over 4. If you divide top and bottom by pi, pi drops out, and basically it is 1 over 1/4, which is same as 1 times 4 over 1. I shouldn't have to show all these baby steps, and it boils down to 1. It's a very simple fact that you should have at your fingertips. You should realize right away that if the radius of the circle is twice as much as some other radius of some other circle, then the bigger circle is going to be not twice as large, but 4 times as large. Why? Because the radius is being squared. It's pi r squared. The radius is being squared. That's all it is. That's it. We are done. It's 4 times as large. You see? If the radius of the small circle, watch here, if the radius of the small circle is let's call it x, and if the radius of the large circle is 2 times x, then what happens? Here it's going to be pi r squared, which is going to be pi times 4 times x squared. You see, that's why it's 4 times as much, because this 2 is being squared. And here it's going to be pi r squared. So this is the area of the small circle. This is the area of the large circle. And this is same as 4 times pi times x squared. 4 times pi times x squared, and this is pi times x squared. As you can see, it's 4 times as much. Because of the fact that this 2 is being squared. This pi r squared is pi times 2 squared times x squared. The 2 is being squared. That's all. If the radius had been 3 times as much, then the circle will be 9 times as large, because 3 is going to be squared. It's going to be pi r squared. And if the radius is 3 times as much, it's going to be 3 squared. So it's going to be 9 pi r squared or x squared, whatever it is. And it's going to be 9 times as large. A circle with 3 times the radius of some other circle will have an area 9 times as large. Number 18. Number 18. If the sum of consecutive integers from -22 to x, so we know that they are consecutive. They have to be consecutive from -22 to x. Inclusive, alright? So we have to include the -22 and we have to include the x. We have to include the endpoint. They tell you inclusive is 72. The question is, what's the value of x? Well, let's find out, shall we? These are consecutive integers, starting with number 22, starting with -22 and ending at x. So the very first one is going to be -22, and since they're consecutive integers, the one after that is going to be -21, the one after that is going to be -20, so on and so forth. Then eventually we're going to hit a 0, and then we're going to have, how can I start this thing? Tell you what, I need more room, so I'm going to continue here. It's going to go on to -3, and then -2, and then -1. We're taking their sum, and then finally we're going to have a 0, and then it's going to be +1, a +2, a +3, so on and so forth, and it's going to go to 20, 21, 22. What's the sum so far? What's the sum of these numbers so far? We know that their sum has to be 72. If we start at negative 22 and go all the way up to positive 22, we have consecutive integers here from negative 22 to positive 22. What is their sum? Their sum is 0, because this negative 3 cancels out with this positive 3. This negative 2 drops out with this positive 2. This negative 1 goes out with this positive 1. This 20 is going to drop out with this 20. This positive 21 is going to drop out with negative 21. This positive 22 is going to drop out with this negative 22. Everything is gone. So far the sum is 0. And the next number is going to be 23. So the sum of consecutive integers from negative 22 to positive 23 is just 23. The sum of consecutive integers from negative 22 to 24 is, the sum is so far 47. We need 72. Let's do one more. So 47 plus 25. I could have continued here, but I didn't want to go too low here. 7 plus 5 is 2. Carry 1 and 72. There you go. So now we can see the sum of 23, 24 and 25 is 72. Because everything else drops out from negative 22 to positive 22. They kill each other. They obliterate each other. They destroy each other. They annihilate each other. They're gone. They're gone. So the sum is 0 so far up to positive 22. We need a sum of 72, which means the series must end at 25, which is our x. It goes from negative 22 to x, and we just found out that the last number is 25, which is our x. X equals 25. The answer is 25. Answer is B. The answer is B. That's all. I will see you tomorrow, okay? Bye now.